Following on from the previous video, we got to this stage here. We got to this stage here. We need to change the limit of integration. So in the dx world, we are integrating from 0 to r. But because we made this substitution, we need to work in terms of d theta. So in the dx world, we are integrating from 0 to r. We need to figure out what it means from where to where in terms of theta. Okay, so we need, well, we made this substitution, so we need to figure out these two values here. So in the dx world, we are integrating from 0 to r. So if we put this into x, that will then become this thing here, 0, and then r sine theta. Well, when will this side be 0? It will be 0 when theta is 0. So you integrating from 0 to r would mean, in terms of theta, it would be 0. So it's basically you making theta the subject here. If you divide both sides by r and then inverse sine, that will then give you 0. So this thing will be 0. So now hang on, let me clear this up. So wait there. So now we need to put r into the x, because we need to figure out where we're integrating to. From 0 to where. We need to figure out this thing here. So put r into here. So that will be r, and then over on this side, r sine theta. So what value of theta will make the left-hand side equal the right-hand side? Well, if you put pi over 2 into theta, then the left-hand side will equal the right-hand side. So really, this thing here is pi over 2. So it's really you making theta the subject. So divide both sides by r. That will then give you sine theta equals 1, and then inverse sine, that will give you pi over 2. Well, in the dx world, you're integrating from 0 to r. In the d theta world, you're integrating from 0 to pi over 2. So what that means is this. You've got our circle here. In the dx world, you're integrating it from 0 to r. In the d theta world, you're really integrating it from an angle of 0 to an angle of pi over 2. So you're integrating it from 0 to pi over 2. So what this means is, instead of working in terms of x, we are now working in terms of theta. We are integrating it from 0 to pi over 2. Or tidy this thing up, that will then give us this. So in the previous video, we got to this stage here. We are now at this stage here. Okay, so now this r squared is a constant, so take it out. That will then give us this. So now it's just a matter of integrating cos squared theta. Well, to integrate cos squared, we are going to use this. So we can put this into here. Okay, I'm expecting you to know this. So if you don't know this, memorize this by heart, because you know, well, you're going to use this again and again. You're going to use these two again and again. So you might as well memorize these two. Well, to integrate cos squared, we will put this into here. That will then give us this thing here. Because I'm just breaking this up as a half, and then cos 2 theta over 2. So now it's easy to integrate now. So integrating this will then give us this. Integrate this will then give us this. So now we put this into here. So that would be pi over 2, and then you divide by 2. So that would be pi over 4. This thing here. Put this thing into here. So when you put this thing into here, it will be 2 times this thing here. 2 times pi over 2. This 2 gets multiplied to the top, cancels out, so it's really sine of pi. So it's really sine of pi. Or sine of pi, this is 0, 2 pi, pi is, sine of pi would be 0. So this thing here would be 0. And then if you put this into here, that would be 0. Put this into here, that would be 0. So the whole thing here would be pi over 4. But then you've got this 4 here. So the two 4s will cancel each other out, giving you the area of the circle being pi r squared. Okay?